Hi, welcome to the DataTech. So today we are going to discuss about Spark, and it's completely going to be a practical session. It's like Spark Bootcamp. So before getting into Spark Bootcamp, the practical thing, I'll just quickly take 5 minutes or even less than that to explain few things before we get into the actual session. So Spark practical, it consists of two things, mainly RDD and data frames. Okay. So here today we are going to discuss all about RDD. So in this particular session, it's going to be the Spark RDD. So practically, so in and out, we are going to discuss about this RDD. Data frame in Spark, it's available. It's a next level of RDD, which has advanced processing techniques like which you can use it for Spark SQL, and you can do all type of data transformation in advanced level, which was not there in RDD. So data frames is the next level practical thing. So we will be discussing this data frame in a separate video. So in this video, we completely discuss about RDD only. So RDD consists of two things. We call it as transformations and actions. Okay, so here in this video, I'm going to explain you and I'm going to show you how to work with transformation and actions. So Spark consists of three programming languages support. So we have Java, we have Scala, and then we have Python. So Python Spark is called as PySpark. So today we are going to discuss this complete Spark bootcamp thing through PySpark. So for Java, Scala, and Python, these three supporting language we have in Spark, but for Spark, they are providing this shell, Spark shell, which is otherwise called as REPL, read, evaluate, print loop. So in Spark, you have Spark shell for Scala and Python only, but there is no shell for Java. So if you want to practice something with Java, then you have to use some IDEs like IntelliJ or Eclipse. So I am going to show you all this practical thing regarding this RDD through PySpark shell, not in the Eclipse or any IDEs. But you can even go for Eclipse IDEs like IntelliJ or Eclipse. But still, I'm going to show you in PySpark, and even you can use PyCharm. So I'm going to use PySpark in shell, okay, which is called REPL. So here, this transformation and actions are the two core thing that we use to define or to process data with this RDD. So the full form of RDD is resilient distributed data set. So resilient distributed data set. So resilient is all about you have some data, and the data, like when once you process in Spark, it reads the data and it creates a replication for your data by creating a partition, and for each partition there will be a replication, and that replicated data will be get distributed across the cluster. For example, you have 1 GB of data and you are going to use an RDD functionality on top of this 1 GB data. Now, once Spark reads this 1 GB data, it split this into small chunks. For example, this 1 GB data got splitted into 3 chunks. Just imagine. So now these 3 chunks will be get replicated. For example, like this. So now each of this chunk, or otherwise called as a block, is getting replicated. So this is B1 and this is B2 and this is B3. So now we have these 3 blocks and that is being replicated. So totally we have 3 copies. So now these blocks will be distributed across the cluster. Now you can ask me, so this is what HDFS is also does, right? So like Spark can able to act as a distributed storage come processing without even having Hadoop. You don't need HDFS or you don't need Hadoop cluster to be get integrated with Spark. As a standalone Spark cluster can act as a full-fledged massive parallel processing technology as well as distributed technology for the storage. So you have installed Spark on a Linux operating system in a multi-node. Now Spark will think, okay, there is no such Hadoop file system has been used. So now Spark will do this parallelism by distributing the data, by replicating the data. Spark itself will take care of doing that in memory and with the help of both in memory and disk. Imagine I'm using HDFS for Spark. In that case, your HDFS will take care of all splitting, replication blocks and everything. So Spark will do only the processing part in the in-memory and disk. So when there is no HDFS, Spark will take care of both the work, HDFS work as well as the processing work. Okay. So Spark is efficient because it has the in-memory computation. Even if the memory is full, Spark is capable of doing it on disk and memory, and both memory and disk. Whereas if you take MapReduce, in MapReduce you cannot handle this in-memory computation. It's all about disk. So MapReduce has the problem of more network IO, more disk IO, and more memory IO. Whereas in Spark, we are reducing the disk IO and network IO by doing all the transformation and storing the intermediate data in the memory itself. So that is where the advantage of Spark. Fine. So now we have seen like enough introduction about Spark and RDD. It's not very detailed, so I have very detailed video. It's already uploaded in my channel. So I'm sharing that link in the description box of this video. You can have a look on those videos. Hello. Okay. So now let's get into the practical part. So I have my Linux machine with me. So please do practice all the Spark and any big data related practicals only on Linux. So even though you have Windows and even though you have configured your Spark or Hadoop in Windows, still it won't help you. Please go with any Linux OS to do that. Fine. So here you can see I'm using Spark version 3.2.3 and and you can see here so bin/spark-shell. So this will take you to Scala. Okay, so we have two REPLs. So you can call it as shell or you can call it as REPL. So we have two shell in Spark. For Python, they call it as PySpark shell, and for Scala, they call it as Spark-shell. So you execute Spark-shell, it will take you to Scala. So as I told you, I'm going to show you everything in Python. So let's come out from this. Okay, now I'll go to PySpark. So bin/PySpark. So this will take you to PySpark, and you can see Python version 3.10.12 is the Python version. So once this take you to the PySpark shell, once the PySpark shell is enabled, you will able to see a web port number and a URL because you have a web UI for shell also. So even the code that you execute in shell, you can able to see the progress of job stages and everything in the browser. So you can see this is the page. So this is what the IP address and port number. So IP address is my local machine IP address. So just copy this and go to your browser and then you can log on to the IP and port which has been provided by the Spark shell. So it's not like you have to give the actual IP, even you can give the host name which is localhost. So you can even type localhost colon 4040 also. Fine. Let me go back to the terminal. Okay, so this is Spark shell. So you can see two things here, Spark context and then Spark session. So this is Spark session and Spark context. So let me just give you an overview of what is these two. So Spark context and Spark session, right? So I'll just put SC and SS, Spark context and Spark session, which act like a entry point, which is like a main for your Spark program. So since this is a shell, so the main method has been, that is the Spark session and Spark context has been created by the shell itself. If you are planning to write a code in IDEs like PyCharm or Eclipse or IntelliJ, you have to create the Spark context and Spark session with additionally 2 to 3 more lines of code. And that is going to be the common code. So like across any developers, that is going to be the common code. So since it's a shell which is giving you, and shell is definitely for testing purpose only, and to test the line of code, piece of code, and not for the production. For production, it has to be a file like Python py file, or you have to write a Scala code and Java code. You build that as a jar file, and we will be sharing that jar file to the production team, and the production team will schedule the job. Okay. So now this Spark context is something mainly specified to RDDs. So advanced level of data processing techniques like data frames, and we call it as data set, and then we have this Spark SQL, and connecting to different sources like RDBMS or Hive or Hadoop. So all these comes under Spark session. So RDD is for Spark context. So now you want to only work with RDD, you have to use a Spark context as a main. But if you are planning to use Spark SQL or data frames, then we will be going for Spark session. And one more thing I wanted to tell you, Spark session also supports RDD functionalities. And that means, so if you are planning to work with both RDD and data frame, then directly you can use Spark session. You don't want to go for Spark context. If you are only using RDD, then you can go either Spark session or Spark context. Don't get confused. But for data frames, you cannot go for Spark context. Okay. So data frame, if you ask me like whether you can work with Spark context, no, you can't. Okay. Data frame means it's Spark session for art. Okay. So fine. So now let's get into the, now let's, so now let's go back to the Linux. Now what I'll do, I'll just first show you how to create an RDD. For that I need a data. So let me create a variable data, and then I'm going to create a list. Okay, so now enter. So this is a normal Python syntax. So it's nothing to deal with Spark. So now this is a data 1, 2, 3. This list is a data. Now if I want to use all the Spark, PySpark APIs on top of this data to do the transformation, I need to convert this 1, 2, 3, the list to an RDD. Okay, then only this data will enter into the Spark world. So to do that, I need to convert the data, or I need to create an RDD for this data. So to do that, we have different types. There is several types to create an RDD. So one such type is, so I'll create a variable again, RDD equal to, so this RDD is not a syntax or a reserved keyword, it is just a variable. Even I can go with A equal to SC. So this SC is something that I showed you in the beginning of the Spark shell. Spark context has been created and stored as a name SC. Like it's an object that has been created for Spark context. So I'm just using SC dot, and then you just type PA and tab. When you click tab, it will autocomplete. So that means we have some functions under SC. So when I just put SC dot and if I click tab, you can able to see these are all the function that comes under SC. Okay, fine. Let me clear the screen. So parallelize, and then data, the variable which stores 1, 2, 3 in list. Enter. So now after executing this line, what will happen? So your data has been entered into a RDD boundary. Okay, parallelize. What this parallelize will do, right? So this parallelize will actually create partitions and then distribute the data to across the cluster. So that is what this parallelize will do for your data. So this way you can create an RDD. So this is one way of creating an RDD. So what exactly, when you write a code, there is one more thing I wanted to tell you. So all your Spark programs are lazy evaluation. So what is mean by lazy evaluation? So that means you are writing some transformations in Spark. So transformation 1, transformation 2, and then like you are writing so many other transformations 3 and transformations 4, and finally you are performing an action, like for example write this to a output file. Okay, so this is an action that you are invoking. Now imagine you are writing code for this for transformation, and finally you are not invoking any action. So this all call as a transformation. As I told you, RDD splits into two types, transformation and action. So until you invoke an action, your transformations will not be get executed. This is what called lazy evaluation, right? So imagine you are like learning a course or a degree, right? So you are just doing your college for 4 years, and finally you are not getting your certificate, and it's waste of spending all 4 years, right? So there is no use. Like that, you are writing a lot of transformation. Imagine each of this transformation is being executed, and finally you are not making use of that output, means it is waste of the resource and the RAM scores and everything that you utilized from your cluster. So that's why Spark became lazy evaluation. Even though you have written a function, at last if you no action has been invoked, your Spark will not execute any of the transformations you have written. So we call this as bottom to top approach. Only when the action is invoked, then all your transformations will be get executed, else no. Fine. So now I'll just show you a proof for this. So we have a UI, right? So I just told you there is an UI, right? I'll just refresh this. So I executed this parallelize of data, right? And you will not see any data in the Spark UI, right? So let me show you. So there is no jobs here. See, this is empty. So I have triggered a command sc.parallelize data, but still in the web UI, I didn't see anything, right? So because we haven't performed any action. So we have an action called a is a variable for which we did this parallelize thing and we converted the data to an RDD. Now there is an action called collect. So this collect will collect the data to your driver, that is to your main, and then it just computes the processing and it will display the data as an output in your console. Right, so I'll just give enter. Now the job gets started. So now you can see the progress. Now I'll be getting the output as 1, 2, 3, which is the RDD now. Now A is this A variable is an RDD because we did sc.parallelize. It's one way of creating an RDD. Now let me go back to my browser and I will just refresh this. You can able to see the job. See, you are getting the job. So this job created 4 tasks, 4 input task, 4 output task, and duration is 6 seconds, right? So previously when I showed you, we didn't see anything, but after triggering this a.collect, you are getting the output. So this is the proof for this lazy evaluation. That is bottom to top approach. Once the action is triggered, then only the transformation will be get executed. Fine. Now let's go back to PySpark again. Now we have different ways of creating an RDD. So this is one way of creating an RDD. So there's another way. For example, I'll go with another way. So b equal to sc dot. So you can even read a text file. So this is a function which will read a file from your local file system or from HDFS. Okay. So this Spark has not been integrated with Hadoop yet. If this is got integrated to Hadoop directly, you can give your HDFS path here. So this will read the data from HDFS. Now I am reading it from my local file system. So I have this file. I'll just show you in my local. So vi data, this is my local. So I just open the file data. You can see just hi as a content, right? Now let me go back to my PySpark window. Now enter. So this line b equal to sc.text file. So which is actually converting my data file, this text file data to an RDD. So this is also one way of converting your file to an RDD. Not only text file, we can even read different format of file like sequence file format files and then JSON files. So we have, so this function is called a text file. Like that you have JSON file function and then sequence file function and then you have whole file function. So these are some of the varieties of format that supports to read a file. So this way also you can convert a file to an RDD, a data to an RDD. So now what I'll do, I'll just do b.collect. Fine. Now I can able to see the data high, right? So a function, action has been triggered. So as I told you, there is one more I wanted to show you, which is whole text file. So I'll just create one more sc.whole text file. Now again, I'm going to give the same path. So you can ask me what is the use of this when I have this text file function. So anyway, it is going to read the data within the file. So this whole text file will not only read the data, it also gives the path and file name as an output of your file. I'll show you. Enter. Now c.collect. Now you can see it also prints the file content, also the information about the file name and path of the file. Right. So now path of the file will act as a key and the content inside the file will act as a value. Fine. So this is one way of creating an RDD. And even you can create an empty RDD and you can make use of it later also. So now I'll just show you how to create an empty RDD. So sc dot empty RDD. That's it. So now d dot collect. Enter. So it's an empty RDD. So this way also you can able to create an RDD. So now I just showed you how to convert your data to an RDD. Once the data has been converted to RDD, now you can start playing with your transformations and actions. So let me introduce some of the transformations to you. So the very first transformation I'm going to show you here is map transformation. So map is all about having splitting your data into key value pair format. Okay, so now I'll just create a map function. I'll just use the map function first. So first I need a data set, right? So what I'll do sc.parallelize and then I'll have some data. I'll have some data. So directly you can create a data within Parallelize rather than first assigning it to a variable and giving that variable to Parallelize. Directly you can parallelize by hard coding the data itself. So it's like you have to put Parallelize and then within square bracket, I'll create my data set. Okay, fine. So I have two name. Okay, I have two names here. Enter. So now I have a data which has been converted to an RDD. Now you can even do a dot collect, means you are invoking an action, but yeah, the agenda is map. So to pass this map. So now what I'll do, p equal to a dot map, and then I'm going to write a lambda. So lambda is actually you are writing a function without a name, an anonymous function, and that is the usage of lambda in PySpark. Okay, it's like you are passing a function to a function, kind of. Even you can create a function, def function name, and then you can create, but lambda, it's very easy. So we don't want to worry about what name we have to choose for a function and return types, etc. So directly I'll go with lambda. So x of x comma 1. Now what I'm doing, so b equal to a dot, so a is actually holding this Gautam and Nandu dot map. So now I'm just invoking the map function, and what I'm trying to do after invoking the map function, my Gautam and Nandu will be entered into the world of map, where the map acts as like to split data into key and value pairs. Now I'm saying what should be the key. So here x is actually the key, 1 which is I'm hard coding as a value. So now Gautam will be the key, 1 will be the value. Nandu will be the key, 1 will be the value. So now I'll just do b dot collect. Enter. So you will be seeing Gautam 1, Nandu 1. So Gautam 1, this is one set of key value pair, and this is a second set of key value pair. So you can ask me where I'm going to use this. So you can use this, for example, even in word count we can do this. So I'll just show you an example like how to do this word count programming. So for each and every word has to be get counted. If it is if for example if Gautam appears 2 times, it should say Gautam total count as 2. So in that case, we will be using map to assign a value 1 as a hard-coded value to each of the word that has been occurred in the file. I'll just show you the use cases. Okay, or any key value pair splits you want to do with Spark transformation, you can go ahead and use this map function. Okay. So now next example that I'm going to show you, which is called a flat map, which is similar to map. It's actually similar to flat map is similar to map because it applies a function to all elements in an RDD, but flat map flattens the result. Flattens the result means it will just split the data into individual component. I'll just show you as an example. You can see here. So what I'll do, sc dot parallelize. Okay, so sc dot parallelize. I'm going to give 2, 3, 4. Okay, dot flat map. And I'm going to create a lambda function x of x comma x comma x dot collect. I'll just show you the output first and then I will explain what is this code. So now you can see here I have 2, 3, 4 and I'm giving it to the flat map, and I'm just saying like repeat the values in the list like 2. So first this entire logic will work for number 2, and then again this entire logic will work for 2, 3, and then again this entire logic will work for 4. So that means you'll get 2, 2, 2 because I have x, x, x. I'm repeating the x. So x is nothing but 2 for the first run. Second run, this x will be replaced with 3. So you'll be getting 3, 3, 3. Next 4, 4. So this is what flatten. I'm just flattening it. Now the same code, I'll just remove this flat map and I'll just put map here. You can see what is going to happen here. So you can see this has been created as a 2 created as has been created as a separate element. 3 has been created as a separate element of list, and 4 is a separate element of list. This is not actually called a flatten. So you have some data set and this data set has to be get flattened, right? Then you can go for flat map. So the same thing while doing this word count program, I'll explain you. There is one more difference I wanted to show you when it comes to word count. So that time again you will understand what exact difference of flat map and map. Okay, so you please note it down. Anyway, I'm going to say this by end of the video. What is the difference between map and flat map if I use word count? Fine. Next transformation, filter. Okay, so before getting into it, I just wanted to show you a file in my local file system. I'll just show you. So here you can see I have 3 lines, okay, and it is comma separated. And I'm going to filter the line which has the word welcome. So this is what I'm going to do now. So let's do it. So now I'll just create. So now I just create a variable data and equal to sc dot, it's a text file, right? So I just need to read this. So my file name is, the path is as data underscore 1, enter. So now I'm going to create data dot map. I'm gonna say that my input file has been splitted with comma separated. Okay, so I'm going to say my file is delimited with comma. So lambda line and then line dot split by comma. Okay, so this is the logic because I want to say what is the delimiter first. So now it's the actual part is gonna come. So it's like rows dot filter. I'm invoking the function and then I'm writing a lambda again. I'm writing a lambda and then line. Now I'm giving a logic that I have to get the line which consists of the word welcome. I have to say that, right, in line. So this is what the code. So now I will invoke collect. So I'm saying that I just need the line which has the word welcome. So I just made a mistake here. It's not a semicolon, it is colon. Enter. So you can see I got my output, hi, welcome to the datatech, and comma, welcome to the class. So I have 3 lines, but you can see how are you, the second line is missing because I'm just filtering only the line which has the word welcome, right? So filter. So this is what filter is all about. So here I'm using again this map. So because I want these 2 lines to be shown as a 2 different element rather than flattening it. So flattening it, what happened? If I put flat map here, what happened, right? This thing you will not see. This close square bracket and open square bracket you will not see. These 2 lines will be considered as a one single element, and that is where the difference comes with map and flat map. Okay, fine. So let's get into the next transformation. So the next transformation is going to be the map partition. Okay, so I'll just give you the definition of it. So map partition, it provides the facility to do heavy initialization, for example, database connections. So once for each partition instead of each row. So that is what a map partition does. So also like partition is very powerful transformation available in Spark, which programmers would definitely like. It gives them the flexibility to process partition as a whole by writing custom logic on lines of single threaded programming. Okay. Now imagine, so I'll just go back to my blackboard. I'll just go back here. So now you just imagine that you have a logic. Okay, so you have a logic. So back to MapReduce world, right? So in MapReduce world, so we have map. So number of tasks, for example, the map logic what you have written is running in 4 tasks. Now imagine I have 4 tasks. So task 1, so task 2, task 3, and then the last task is task 4. Okay. Now I have to read a file from RDBMS, which is MySQL. Just imagine a database, MySQL. Okay. So now I just wanted to read the data. Now the thing is, now for this particular mapper alone, I'm getting 1 million records. Like that, for this I'm getting 1 million records. For the third mapper alone, I'm getting 2 million records. And then for fourth mapper, I'm getting some 100K records. Imagine, this is how it happens. So here imagine these are your Spark tasks, okay, and you have written transformation. We did a filter transformation, right? So imagine your filter transformation is running as 4 tasks in Spark cluster. So you are having 4 tasks here. Now the thing is, the logic what I have written in Spark has to run for. So here you have written a task, whether the task will run for each. So there is a question. So listen carefully. The transformation what you have written should run for each row or for each partition. So this is a question here. Partition. So that means you have written a filter logic, right? So this filter logic will work for each row or it works for each partition. So once for a partition or each row. Now we have certain cases, right? So imagine now I want to create a database connection, and this database connection, imagine if it is runs for based on the record, right? Row, and it creates like 1 million. It creates, so it creates like 1 million connection. To read 1 million rows, you need 1 million connection. If you are not aware, you can check with some DBS, database developers. So 1 million connection is huge, guys. It's huge. So, 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 so 1 million connection is huge, guys. So you can check with any DBS just for reading 1 million records from RDBMS. You don't need 1 million connection. Just 1 or 2 connection is wide enough to read 1 million connection. So imagine I have such use cases where the logic what I have written should be get executed once per task, but not for each rows. Okay, only for one task. If you take filter works for each row. It has to be get worked in that way. But imagine I have a use case where I create a DB connection, and this should be get created. This Spark code which I written for DB connection should just execute only once for each partition, not for each row. In that case, the DB connection code should run only 4 times because I have 4 partitions only. That is 4 tasks. Okay, so in that case you can go for map partition. So in map partition you can write a custom logic, and this logic will be get executed for each partition instead of each row. Okay, fine. So let's get into the code. Okay, now let's start the practical for map partition. So now what I'm going to do, I'm just going to create a range of 1 to 10. So range is like in Python we can generate a values with a range function. So I have to convert this to parallelize function like RDD, right? So sc dot parallelize and then a. So now this value is, and with this value like 1 to 10 has been converted to an RDD. So let's see with collect for action. So you can able to see the data now. It prints 1 to 9. Fine. So now what I'm going to do, I'm going to create a function. So def f of iterate. So iterator is a function. I mean, sorry, def f is a function. I'm just invoking the interface iterator of, and the return yield. So yield is like what I'm gonna get from this. I'm invoking the aggregate function sum of iterator. Okay. So now you have to hit one more enter. So this will come out. So now what I'm going to do, I'm going to invoke the data with the map partition function. Okay, map partition function of f dot collect. So let me tell you what is happening once I'm getting the output. So this map partition, via this map partition, I have created a function, and this function will be get executed, a custom line function which will be executed for each partition. So now you can see I'm getting 4 outputs because 4 partitions has been got created. See, we have range of 1 to 10, right? So I have 1, so till 9, right? So now if you see, like we have 4 outputs, I can show you. So we got 4 outputs. So you can see 4 outputs because 4 task has been got created. So by default, I haven't given any partitions. So number of task I didn't mention. So based on the resource availability, so the default task parallelism got created is 4. I can even prove you that. So what I can do, sc dot default parallelism. Okay, so this is a function which I can invoke, and I'll show you. Okay, it shows 4. So that means the default parallelism for this particular environment is 4. So that's why it created 4 partition for your data from 1 to 9. So each partition has 2 digits, 2 values like 1, 2. So if you see here, like this 9 number has been get splitted into 4 partitions. So for example, if you take first output 1 and 2 for went to the first partition. So the output of first partition is 2 plus 1, 3. And then the second partition, it is 3 and 4. So 4 plus 3 is 7. So for next partition, it is 5 and 6. So it is 11. So for the next partition, it is 7 plus 8 plus 9. So the remaining all data went to one partition. So it is 24. So here, so partition 1 and partition 2, partition 3, partition 4, like distributed the data, and then it is giving the output of each partition. So that's what I was trying to show you in the whiteboard. So if you take like partition 1, so P1, it took numbers like 1 plus 2. And then P2, it took the number like 3 and 4, etc. Okay, so imagine now if you ask me like, can I give the number of partition that during the creation of RDD? Yes, of course you can give. So you have to go back here. So parallelize a comma. For example, you need 3 partition. While creating the data to an RDD, you have to mention it. So now I'll again invoke the function, and then I'll just invoke this map partition thing. So now you can see 3. So now what happened, right? So for each partition, now 3 partitions only created. So in first partition, 1, 2 and 3 entered. So 1 plus 2, 3, 3 plus 3, 6. And then 4, 5, 6. 4, 5, 6 entered into second partition, which is 15. And again 7, 8, 9 entered to the third partition. So 7 plus 8 plus 9 is equal to 24. So here I have showed you 2 things. One is the map partition by creating a custom line function. So this map partition executed for each partition. And also I showed you a function called default parallelism. So this will show you the default parallelism in your environment, which is 4. Now I changed it to like, what can I say? So now I changed it to 3. So that also we can check. So now I can show you that this particular 3 is working or not. By showing you the output, I've proved that only 3 partition got created, but still you can able to get the value. So now B dot, so B is the RDD for which I created this a comma 3, which is the data with 3 partitions. So we have a function called get num partition. So I can invoke this. So it will give you the number of partition 3. See, I've proved you that 3 partition only got created. Okay, next transformation. So let me show you the next transformation. So it's all about union. So the next transformation I'm going to teach you is union. So union is all about you have 2 different tables and you have to do an union of these 2, and then you have to start your transformation. So in that case, like, this will be helpful for you. So now what we can do, so I'll just create 2 variable. So RDD1 equal to sc dot parallelize of range. So instead of creating range and then parallelize, you can directly do this way, enter. So now the same thing, but I'll change this value from 5 to 15, and then I'll change the name to RDD2. So now what I'm going to do, I'm going to do an union between RDD1 dot union of RDD2 dot collect. Okay, so now you can able to see the output of first 1 to 10 range. So it will print 1 to 9, and then 5 to 15 you can see 5 to 14. So here you can see 5, 6, 7, 8, 9 got repeated. Okay, so it is not avoiding the duplicate, as is it is doing a union between these two and it is giving the output. Now I can do there is an opposite of union, right, which is called intersection, right? So let me show you the next transformation, intersection. Okay, so this will give you for both like RDD1 and RDD2 the common unique factor. So it is like 5, 6, 7, 8, 9. So it is not in order, but the common numbers between these two ranges is 5, 6, 7, 8, 9. Okay, so that is what an intersection is. Now I need to do an union, but I have to eliminate the duplicates. So what you can do, you go back to the union function. Okay, and after this RDD2, you add distant. So this will eliminate the duplicate. Now you can able to see, you can see it is not in an order, but you can see like 5, 6, 7, 8, 9 is not repeating. You can see the length of this list and the length of this list. By seeing the length itself, you can understand like some of the numbers have been eliminated, which is like duplicate is eliminated. So this is the 3 important function that we need to know with respect to union and intersect. And in union, we have seen the distant also. So the next one, let's do join. So joins in RDD. Okay, so let me create a data set. So x equal to sc dot parallelize, and I'm going to create like values. Okay, Gautam, comma, Nandu, comma, Rahul. Okay, so I'm creating this data set and I'm invoking the map function with lambda because I'm going to assign a value for these names. Okay, I need to have two columns and then only I can perform the join as an example, right? So a comma 1. So I'm assigning 1 along with all these values. Okay, so even you can like do x comma collect, you will see the output in that way. So now the same thing I'll do with y sc dot I need another data set, right? So in this I have to create one common case. So Saru, and then I'm sorry, and then I'll go with the name Gautam again. So you have this common name between these two, so via which we can able to see the output of join perfectly, right? So I again create a map function with the lambda of a repeat. It's the same thing. Okay, now what I'm going to do, I'm going to perform the join x dot join of y, okay, dot collect. So you can see the output now. So Gautam 1 comma 1. So it's join means whatever the record is matching with between these two RDDs. Okay. So now even we can do left right joins also. So instead of join, let me go with left outer join. Okay, so left outer join. So now you will see Gautam 1 comma 1. Along with it, it will print all the left hand side values. When I say left hand side values, this one A. So it also gives Rahul and Nandu, but still you can see the second argument is none because it is not matching. So the same way you can do for right. Okay, so now you can see Gautam is again matching between these two, but the right hand side is Y, this record. So again, you can see the Saro and Nila comes with this side value as none. So before, like for X in the left hand side, you get none in here. Now here you are getting. So it's like right join and left join. So right join gives you the right records along with the matching one. So left gives you the left records along with the matching one in right. Okay, so this is how we do joins. Okay, so now the next transformation is group by key. Okay, so I wanted to tell you something. So in transformation, we have two types. Okay, so in RDD, I said two things, transformation and action. So in RDD, you have two things. So one is called transformation, one is action. And in again transformation, you have two types of transformation, which we call it as narrow transformation and wide transformation. So narrow transformation means, for example, you are doing a T1 transformation and there is a 3 task. Okay, and then again you do one more transformation, like one more output will be get created from the previous transformation. So this is what we call it as a narrow one to one. Okay, so now we have a transformation. So this is all like narrow transformation. So we have transformations called wide transformation, where this sort by key, group by key, reduce by key, aggregate by key, combine by key. So all these are called wide transformation. So when you trigger a wide transformation, right? So what happens, right? So output of all the narrow transformation goes to each and every task in the wide transformation, and that means you can see here. So transformation 1 from narrow goes to the first wide transformation, and narrow transformation 2 output goes to first wide transformation, and narrow transformation 3 output goes to first wide transformation as input. So this is what happened for the remaining wide transformations also. This is what going to happen. So now in the diagram itself, you can see there is something getting created here, right? So we call this as shuffle. So the data movements happening over the network. So this is what we called as shuffle. So when you trigger this filter map, flat map, and all these transformation, whatever we discussed, this union and all, join, we call it as a flat transformation. So there won't be any shuffle. So when you start triggering this group by, reduce by, combine by, whenever you see this by, right, it's all like a shuffle transformation, which we call it as a wide transformation. Okay, and it all plays with the memory and disk IO a lot. Sorry, memory and network IO a lot. And whereas when there is a less memory you have, then it does the computation by placing half of the data in the disk, and then it will process. Right, Spark does both in memory as well as memory plus disk, and only disk. For all these three is possible. So I'll detail explain you the storage and persist catchy thing in the end of this video. Fine. So now the next transformation what I'm planning to show you is a wide transformation, which is called group by transformation. So all your aggregation happens here. Okay, all your aggregation happens here. Okay, so let's do the group by thing practically. So I just have to create a data set. So here you can see I have created a data set, data equal to a TV 1000. It's like a product, and the amount of the product, phone 3000 and TV 3000. So let me do the parallelize for this. So sc dot, so a equal to sc dot parallelize of data, right? So now I'm converted the data to an RDD. So now what I'm going to do, so RDD dot group by key. Okay, here the variable is a. So a dot group by key of dot. So we have to invoke a function called map values. So here I'm going to pass length of this particular RDD. So len and then collect. Now you can able to see, so TV2 and then phone 1. So what happened here, right? So it is doing the group by key. So here TV is key, amount is value. So if you see here, like I'm having 2 times the TV, so it just grouped the key, and values, I have 2 values in the list. So I'm converting that value as a length. So if you see here, 1000 is 1, and here TV again 3000. So I have values 2, right? One value is 1000 and the second value is 3000. So map value of length means it is considering the map's value only. That means this part. So it has 2 value. So here this 3000 plus 1000 is not doing the summation. So for summation there is a different concept that we have to go with. So here what I'm doing, I'm just trying to count the number of keys, that is number of products, and the sales of it. So now what I'm getting, so TV, 2 products of TV has been sold out and 1 product of phone has got sold out. So here grouping happens on the key, not on the value. Okay, so now there is a next concept which I wanted to show you is reduce by key. So here I'll use the same. Okay, I'll use the same parallelize, a equal to sc dot parallelize, the same thing. So now what I'm going to do with this a, right? So with this a, what I'm going to do, a dot, the a is actually the parallelized data. So now what I'm going to invoke is reduce by key. Okay, so reduce by key of lambda. Okay, and a comma b. So lambda, it's like an anonymous function which I'm writing. So now I'm trying to do a summation. Okay, so for the data, fine. So now I'm going to do an iteration for element in b dot collect. Okay, for element in b dot collect. So I'm going to do, sorry, one second. So I'm going to do print of element. Okay, so now you will be seeing the output TV 4000 and phone 3000. Now the summation has happened. Now this reduce by key internally, what it is doing, right? It is doing group by key and also it is performing the summation. So now TV and phone. So TV 2 times it has been got grouped and then I'm getting the summation. So I'll just explain you what happened in the background. Okay, so let me explain. So now I'm having TV and then phone and then TV. So first I'm having 3000 as TV and then 1000 one more product, and for phone how much it is? Okay, phone is again 3000. Okay, so now what reduce by key do? First it will try to group this key, two key to one. So TV of 1000 comma 3000. Okay, 1000 comma 3000, and then it takes phone. So phone I have only one time, so phone of 3000. So next we have written a function, right? So a plus b, right? You can able to see here I did a lambda function, and then I'm iterating the element in the RDD, the list, and I'm doing the summation a plus b. So first it will so the first this whole line will execute, this whole line, right? It will execute for TV. First it will take TV, it will do the sum for 1000 plus 3000, and once the list has been empty, it goes for the next product, which is phone. So now I'll be getting in the output as TV as 4000 and phone as 3000, because in phone we don't have any other key. So it is doing both group by key and then it is doing the summation with the logic what we have written. So reduce, group by and reduce, both is happening. So here we discussed two wide transformation, which is group by key and reduce by key. In both this wide transformation, shuffling was happened. Okay, so the next one is short by key. Okay, so group by key, it's grouping. So here sort by key, which actually tries to sort the key, but it won't group anything. Okay, it's just quite opposite. So let's have our existing RDD which we have already, right? Let's have that, which is this A. Okay, so now what I'm going to do, so RDD equal to A dot, okay, so A dot sort by key, okay, of true. Now RDD dot collect, enter. Now you can able to see, so alphabetic wise phone comes first, okay, so and then only P comes first and then only T, right? So now we are getting the key in the sorted order. If it is number, it takes the number order wise, ascending to descending. If it is alphabet, it goes with the alphabets, ascending to descending. So here, like we get the output in the sorted order. So we discussed group by key and then sort by key and also reduce by key. All these are important and wide transformations. Okay. So next, let's go for aggregate by key. So aggregate by key is quite important function that we will be using, and you need to understand, because reduce by key and aggregate by key does the same thing, but there is a difference that we should understand. So first, I'll tell you the definition of it. So aggregate by key is logically same as reduce by key, as I told you, but it lets you return result in different types. Okay, so in other word, it lets you have a input as type X and aggregate the result as type Y. For example, you have 1 comma 2 1 comma 4 as an integer as input, and you will get 1 comma 6 SIX. Okay, 1 comma SIX, you gave integer as an input, but you are getting the output of summation as string also. Okay, so it also takes zero value that will be applied to the beginning of each key. Okay, so now I'll tell you in detail. Okay, let me go back to my blackboard. Okay, so what this aggregate by, and it also gives you a lot of performance optimization. First, aggregate by key accepts 3 arguments. Okay, it needs always 3 argument. It starts with 0 for each key. It actually starts with 0, and the second argument, what you will be seeing, we call it as a combiner argument, and the third one we call it as a reducer argument. Okay, so aggregate by key takes these 3 arguments from you. Now imagine, let's go with the traditional example, map reduce. So map 1 and map 2, and you have like a reducer. Okay, so you have a reducer. So I have 3 maps. Okay, you have 1 reducer. Now imagine, so in the reducer I have written a summation logic. Okay, in the mapper I'm getting values like, okay, TV1 and then TV1 and then phone 1. So this is from first mapper. From second mapper, TV1 phone 1 phone 1. Okay, and then in last mapper I'm getting TV1 phone 1. So now I have to send all these output of mapper to the reducer. Now imagine, for each record it takes 1 network IO, but it won't happen in that way, but I'm just telling you each for each. So 1 2, it all goes to reducer like this. Okay, it all goes to reducer like this. So now count the network IO: 1 2 3 4 5 6 7 8. So totally you have 8 IOs. Okay, now what if we do a, what if we run a mini reducer on each mapper? Now I'm going to run a mini reducer. Okay, mini reducer, that means I'm going to copy the logic of reducer and run for each mapper. Now what will be my output, you know? Okay, so TV of 2 phone 1, because what logic we have written in reducer, sum. So instead of running for all the mapper, I'm going to run the reducer for each mapper. Now I'm getting 2 outputs instead of 3. Now for the next one, TV1 and then phone 2, it is doing the summation. And for finally, so this is, there is no need of summation here because we don't have any repeated product. Now this mini reducer output goes to the reducer. Now let's count the network IO. Okay, 1 2 3 4 5 6. So now it is 6 IOs only. So that means this mini reducer is otherwise called as combiner. In MapReduce we use this. Even in Spark we have the concept. Okay, combiner. What this combiner does, right? It actually tries to run the mini reducer in the mapper side itself for each mapper. Okay, that is what this aggregate by key is doing. So the second argument what you write, which runs for each partition, and finally the logic what you run in the third argument will be get executed for overall for all the partitions output. Okay, so this reducer logic was this, and this combiner logic what you write is the mini reducer. Okay, now let's get into the aggregation. Okay, so let me get into this practical thing. Okay, what I'm going to do, I'm going to create a file. So for that, what I'll do, I'll just open another window. So let's try to create a data set first. So what I'll do, I'll just do data underscore one, enter. So I'm going to create a data set. So let me give a serial number, name, comma, count. Okay, so one, Gautam, and count two. And then I'm going to run a one more, like 2 comma Gautam comma 3. Okay, imagine count is something like heartbeat count or whatever it is. Now 3 comma Nila comma 1 and 4 comma Nandu Nandu comma 3. Okay, let me close this, and this file as header. You need to be very much aware of it. So we have header here. Now what I'll do, so I'll just do an aggregate by. Okay, so first let me start reading the file sc.text file. Okay, text file, and it is like the path is home slash Saravanan. Okay, and then your data. So data underscore one. So let me, so I created an RDD. Now A equal to name dot, I'm doing a filter because I just first want to remove the header from the data. That should not be get considered as part of the data. So what I'm going to do, I'm just writing a filter function with the lambda. Okay, so line colon count. Okay, count not in line. So that means I'm removing the line which has the keyword which matches the word count. So that entire line will be get removed. So I have one column count, right? So and I have to mention the delimited also. Then only this count, the filter will work. So I'll show you that file once again. Okay. So let me open the file. You can see I want to skip this line. The first line I want to skip the count. So I'm saying whichever the line has the word count, remove the whole line. And I have to say the delimiter also. Then only it will work. So lambda of line and line dot split. I'll say comma. Okay. Now completed. Okay, so okay, I just did a spelling mistake here. It's filter L missing. Okay, so now this is done. So now B equal to A dot map of lambda n. So now what happens, right? So I have to just give the output of, like, it should be like Gautam 5, Nila 1, Nandu 3. I have to get like this. I have to do the summation. Okay. So now what I'm going to do, I have to filter only two columns out of this three. Okay. So since I've done this map line dot split by, now each element comma separated will be get stored in an array. Okay, so now I have to get the position of it. So if you see here, like this starts, serial number starts with 0, name starts with array of 1, and count is array of 2. So that means we have to take array of 1 and array of 2. Okay, so n string of, okay, string of n of 2. Okay, so it's square bracket because of array 2, and then int of, so the last one, so the count is actually an integer. It should be an integer, right? Because currently it is in string. Now I'm converting this to an integer, that's why I'm giving int of. Okay, so now dot aggregate. Okay, so it should be three brackets, right? Yes, exactly. Fine. So now it should be aggregate by key of, so as I told you, aggregate by key accepts three arguments from you, and here only I'm going to write the logic of summation. It starts with 0 always, and then I'm going to write a lambda function. I get this as a key value pair, like Gautam 3, Gautam 2, like it is going to be the key value pair for me. So k plus v. Okay, so here this key is like, okay, let me put this as an integer. I'm sorry. So this is not an integer. So k plus v, which is the combiner one. This is a mini reducer which runs for each map task. Okay, the input task. Now again, I'm going to write one more lambda, k comma v colon k plus v. Now dot collect. Okay, so it says index out of range. So that means the index value what I have given here, it is not working as expected. Okay, so let me go back and then I'll change this. So 0, okay, it is 0, 1 and 2. I mentioned as 2 and 4. I'm sorry guys. So it should be, so name is 1 and then the value, the count is 2, right? Okay, it's my mistake. Okay, now let me invoke print of B, enter. So now you can see Gautam 5, Neela 1, Nandu 3, right? So Neela and Nandu, there is nothing to do with, right? So you can see here, like they don't have any repeated value. So Gautam 2 and 3 has been summation. So I did a sum of Gautam 2 and 3, so it is 5. So now what happened is you executed the same logic only in both combiner and reduce logic. So that is what in the diagram I said. So you have a sum logic in the actual reducer, but you are running it for each task to reduce the network IO. This is what combiner does in the map reduce. So same functionality you can achieve it by aggregate by key. So initial is always 0. So you can ask me in the combiner, can I write a different logic? Of course you can write. So the combiner and reducer logic can be different also. So this is what aggregate by key. So when someone asks you what is the actual difference between reduce by key and aggregate by key, the one different is like the result set can be in any type. That is one different people always used to say. But you can say this example. Okay, it acts as a mini reducer, which actually tries to reduce the network IO. Okay, and even the memory IO. Right. So this is the actual answer you can say. Fine. So I'll just show you another function which I wanted to show you, but I already showed you that. So the next one, I just wanted to show you a function called get num partition. So a dot get num partition, which is our RDD, right? So we created this as to, if whenever you want to see how many partition has been allocated for an RDD, you can use it with the help of this. So now, as I told you, like you can increase the partition while creating an RDD itself by giving comma 3. While creating a RDD, you can just mention comma 3, comma 4 by increasing the partition. So we have another way to do this. To decrease and increase, we have two concepts called repartition and coalesce. So I'll explain what is repartition. So repartition is a method. It's a very expensive operation as it shuffles the data from all nodes in a cluster. So when we have to use repartitions is, for example, you have to increase the partition, right? So you have to use repartition. For example, I showed you 2. Now I want to increase the partition of it. So what we can do is, so I'll just put dd equal to a dot repartition, okay, of, I'm giving 6. So now dd dot get num partition, you will be seeing a 6. So initially it was 2, now I converted it to 6. So this involves shuffle, guys, because the data movement will happen from a node to node. From the existing partition, you are creating a new one by copying the data to the new partition. And the next, coalesce. So coalesce is actually tries to reduce the partition, but the shuffle movement will be very less. In internet, people used to say in coalesce no shuffle. No, it's not like that. Shuffle will happen, but minimum. Whenever I say the word shuffle, it's like data movement between the partitions. Okay. So now the same thing, but let's go with instead of repartition, I'll go with coalesce. So COA, coalesce. So now I'll make it to 1. So A was actually 2 and then we changed it to 6. Now I'm changing it to 1. So dd dot get partition. So before it returns the output as 6, but now it returns you 1. See, that's it. So these are all the some of the transformation. So far we discussed is all about like completely transformation. So we have been seeing only one action so far, which is called collect. So now let's get into the action. So RDD has two types, transformation and action. So in transformation we have discussed about narrow and wide transformation. Now let's jump into the action. So far we have seen only one action, collect. So I'm going to show you other actions that we have. So first, further I'll create some data. Okay, so sc dot parallelize of so let me create something like this, hi comma a comma b. So now what I'm going to do, there is a action called count. It just gives you the values, number of values that we have in the file or the data. Okay, so now let me put c equal to words dot count. Now we can print this C. Now you'll be getting 3 because I have 3 elements in the list. So this is one action. So now the next action is reduce. So reduce is an action, and it actually aggregates, and based on the operator that we give. So for example, I have to import an operator here. Operator import add. Okay. So now sc dot parallelize of, I'm going to give some value here, 1, 2, 3, and dot reduce. So I'm invoking the action, and I'm just passing this operator. So this operator will be get executed by aggregating these data. Okay, so now let me just enter. So I'm getting 6. So it is just doing 1 plus 2 plus 3. So obviously 6. So reduce is also an action, and the next action that we're going to see is first. Okay, so now it just give you the first element, first data in the element. So a equal to sc dot parallelize. Now I'm going to pass Gautam comma Nandu. Now let me close it. Now what I'm going to do, now a dot first. So this will give you the first element in the list. Okay, so this is again an action. Okay, so we need some of actions which need to be get triggered the whole transformation. It could be collect or count, or it could be this first, so which will trigger the whole transformation. Okay, while testing purpose and all, we use this count or take. There is another function take, so I'll tell you what is this take action is do action does. So take is the next thing that we're gonna discuss. So works by first scanning one partition and use the result from that partition to estimate the number of additional partitions need to be satisfied the limit. So that is what take does. So let's take the same example. Okay, so let's take the same example. Now what I'll do, a dot take off 1. Okay, so now a take off 2. So it's based on the numbers we give, that many records will be get retrieved. So now we have take sample also. So similar to take, in return size of n, includes Boolean option of with or without replacement and random generated seed, which defaults to none. Okay, so it randomly gives you some values from the input what I have given. So take sample is another function. Okay, so it should be like this. So take sample of, I have to enable this, and then I have to ask for some sample 1. Okay, I'll just put this way. So I'll be getting, so you can think like what take and first and take sample is giving the same output. It is not because of that. So because I'm giving only less value, right? So maybe I can add more value. I can show you an example by adding more value. Okay, so I just created more value to it. So I'll put 3. Okay, so you can see CF and Nandu. So randomly it picks some 3 values from the list. So this is for sampling. So take sample. So the next one, we have something called count by key. So it counts the number of elements for each key and return the result to the master of the dictionary. Okay, so let me show you some example here. I'll take the same. So this thing input itself we can take. So I'll create a function, a map. So lambda of k. I'm creating a function. So k comma 1. So always the map functions will be like this. So count by key dot items. Enter. So now you can see this is giving me the output Gautam 1, Nandu 1, C1, F2 times, right? So I'm getting F2 times. So this is count by key. It's again a kind of an action come transformation. Okay, so this is giving the output in this level. And one, I'm going to show you the final action item now, which is called a save as text file, which is a wonderful function. Finally, once you do all the transformation, you have to save it as a file, right? Either it could be HDFS or in your local file system. So we have something called a dot save as. So when you do a tab 2 times, right, you will be getting what are all the save as extensions. So save as Hadoop file, save as sequence file, and we have pickle file, text file. So I'll go with text file format. I'll just save this as a text file format. So I'll create slash home slash. So we have the username. It's like, okay, so I just need to copy the username from here. Okay, so it's this. Let me paste it. dot test. I'll write my output as test, or let me write it as output out.txt. Okay, so enter. So now if you go back to your home and just give ls, you can see the file. Okay, let me open it. So out.txt, see, it got created. So okay, so just a minute. So one thing we need to know here, so the save as text file will not create it as a text file. First it will create a directory, and within the directory only it will create the files as output. So that is one thing I just forgot to mention. So even though you give .txt, this out.txt created as a directory rather than a file. So let me create a new one. So mrout. Okay, so now this created a directory here. Okay, so cd mr out, yes. So now if you give ls, you will be seeing the output. So success mention, it is mentioning that the job is success, and you can see the output has 4 partition. The reason is it has 4 partition. Now I'll get the number of partition, get num partition. You will be seeing 4, and that's why you got 4 output files. Now this Gautam Nandu CFFR has been splitted across these 4 partition, and we don't know the data resides in which particular partition is. So let me first do one thing. So I'll just do a cat of this, what output. So Nandu and C is in first partition. So what about the third partition, which is part 002? Okay, I'll just cat this. You can see F, right? So like this, the data gets stored in a different so like this, the data gets stored in a different part file, and we don't know which part file has the data. So you can ask me like, what about who actually decides this placement allocation? Like Gautam should go to first partition, a C and F has to go to second partition. So in Spark internally, it has an algorithm called hash partition, which decides which partition file should have the data. You can ask me, can I decide, for example, Gautam should always go to part-003? Can I decide? Yes, you can decide that by writing a custom partition in Spark. Okay, in Hive we do this, right? So hash partition and custom partition. I have this content in my previous video. I will share that video in the description box of this video where you can watch it. It's a very big topic to discuss actually. So you can just use that video to understand how exactly this particular file has been decided by the Spark. Fine, what is next? So we have done with the important actions that we do in use in our daily life. So now we discussed with the transformation and action. So now I want to show you few more things before we wind up this session. I just wanted to show you the storage levels that we have. By default, we have the storage level as cache, so which stores the data, the intermediate data in the memory, and we can also change it to memory and disk or only memory. So we have these options. So I want to show you something on that area too. So first what I'll do, I'll just import the needed thing. So import PySpark, but it is not required because we are in shell. So that import is not required. I just forgot. So okay, so let me create a word. So I think we have that already. Okay, let me just take one input file. Okay, let me take this. Okay, so now what I'll do, I'll just do this a dot catchy. Okay, so now I'm just getting this into my cache, into my memory. Now I'll just create a variable c equal to words. Sorry, it's a, because a is actually holds my data Gautam and Nandu. So now I've just did a cache of this a. Now the data is in cache. So now what I'm going to do, I'm going to invoke this persist. So persist dot is underscore cached. So what this output I'll be getting, right, whether the data has been cached or not. So this is what the output I'll be getting. So now I'm going to print this C. It will be returning true because my data has been cached. So that's why I just wanted to show you, but a.cache will not show you whether it has been cached or not. So instead of that, you can use this persist.cache. So all this cache, disk, memory, everything comes under the persist function. So I'm just checking whether this A, that is the RDD, is being cached already or not. So it is saying true. That means it has happened, right? So what are all the other persist storage formats that we can use? I'm going to tell you that. So I'll be creating RDD1 dot persist. Okay. So now PySpark dot storage level dot memory underscore and underscore disk of 2. So this is one way of storing your data. So which means it does. Okay, so okay, I have to import this. Just a minute, I'll be doing it. I thought in shell it is not required. So let me import this. Okay, it's about again using the context only. I would have used it directly. Okay, fine. That's fine. I would have used directly this SC itself, but that is fine. Okay. So now you can see I am using this RDD one.persist, and the storage level I'm using is memory and disk too. Okay. So now I can able to even print this and show you like a print of RDD1 dot get storage level. So this will show you what is the storage level that this particular RDD is using. Disk memory serialized to. So that is what this disk and memory. So that means my data will be get stored in memory first, and if the memory is full, it automatically stores the data in the disk by doing the serialization into 2 times. Okay, it does the serialization so that it will be in the different compression format so that IO will be get reduced. It's like performance optimization and storing the data with memory and disk by applying some compression. Okay, so you can ask me how many storage levels we do have. I'll show you something. So you can see we have disk only 2, memory and disk 2. When I say this 2, right, it is this 2x of serialization. Okay, and we have memory only 2, memory only serialization without disk. So memory only serialization 2 times. Okay, and the off heap. So these are some of the storage formats we have. But basically, when in interview, right, you can just say disk only, memory and disk. That's it. Along with it, we will be doing the serialization. That's it. Only 3 types along with serialization, right? So this is what I wanted to show you along with this persist. So cache is default. So persist is where like we used to decide the storage formats. Okay. So finally, we have to see a word count program. So, and also I said I'll be telling you the difference between this map and flat map, right? So now what I'll do, RDD equal to spark dot, sc dot text file. Okay, so I'm going to read my file. So I'll just show you my file here. So cat. So I have like hi space. So I have to count the words. Okay, so let me add few more words also. Enter welcome, enter to the class. Okay, fine. So I'll just give my word path. Okay. So now what I'm going to do, RDD2 dot RDD2 equal to the first one RDD dot. I'm going to use a flat map here, and the condition here is I'm creating a lambda function says that my input record is comma separated. So x dot split enter. So now RDD2 dot collect enter. So now you can able to see the record has been flattened. Okay, so it is completely flattened. Now you can, okay, so same thing I'll try to do with map. Okay, I'll try to do with map. Enter. So now you can see here all this high comes into one element. So that means if I do a word count with the map by giving the split by, right, it what it does, right? So it take all this and then it will put 1, and it take this list and it will put 1. Now imagine I have one more line in my input file. Again, one more line welcome comma welcome, and it takes that two welcome as to one list, and then this first line, second line two welcome as one list, and then it will put 2. Okay, it is going to do a line by line word count instead of doing word by word count. That is very important to understand. So why first of all we have to flatten the record is, see here the 3 lines of records what I have given has been flattened, and it is giving me only the words. It is not considering about the lines that we have. But here when I use map, right, it is considering the line and it is not doing the flatten, and that is what the importance of flattening the record. Okay, let me flatten it again. And then now what I'm going to do, I'm going to call the map function because I have to add a value with all these words. Hi one, welcome one, to one, the one, class one, like that. I'll show you the output now. So what I'll do, RDD2 dot RDD2.map of lambda, and I'm going to make this as key value pair. So x of x comma 1. Enter. So now RDD3 dot collect. Let's see the output. Okay, so for each word I can, you see I'm getting 1 here, right? So now I am going to invoke the reduce by key because we know already what reduce by key is gonna do. So I'll be getting it. I'll be getting the summation. Okay, so now I'm going to invoke reduce by key. So RDD 3 dot reduce by key. Okay, and I'm going to write a lambda a comma b semicolon a plus b. I just have to do the summation. So it will take high and then it will group the high. So these three high will be, so what reduce by key do first, right? It groups the key first. So I'll just go to my blackboard. So what does reduce by key do? It first try to group all the high to one high, and then it will put the values to list three times high, right? It will put like this, and then it will take welcome. It will group all the welcome, and then it will put the values in the list like this. So now this reduce by key, and then it will iterate these three values, and then it will do plus. So we have a plus b, right? So now first here 1, this 1, and then 1. So now this will change to 2, and then the last one will be here 1. So totally 3. Okay, so this is how this reduce by key will do. Now back. So a plus b and then dot collect. Enter. So now you can able to see welcome 2 times and then hi 3 times, welcome 2 time, 2 1 time, d 1 time, class 1 time, and I have an empty line that is 1 time. That's it. So word count has been done. So now we have done with word count. Also we discussed with the map and flat map, and here in the word count we used flat map, text file, map as 3 narrow transformation, and reduce by key we used 1 wide transformation, and collect 1 action. So we discussed, we have seen in one example like both narrow and wide transformation and 1 action. And also I wanted to show you, I said like this is a bottom to top approach, right? And if you want to see a lineage, so I want to see a lineage, like what are all the transformation has been invoked in my code. So how to see the lineage? So we can able to see the lineage of it. So what are all the transformation has been invoked and all this thing we can able to see. So for that what I'll do, let me invoke RDD3, okay, dot to debug string. So this is a function that we use to debug something. So enter. So this will give you the output of the transformations that we have done. So you can see collect is the last step, and then the previous step was like we did a map partition, and the previous first step is text file. So we could able to see all the transformation when I invoke this to debug string. And also not only this, even in the web UI you can able to see the data lineage in the Spark job. So in this video we were been working with this RDD, especially RDD, and this is wide enough for you to say that you are aware of RDD and you have some hands-on experience. You can Google through a lot to see like what are all the other actions and transformations available, and you can do some sort of practicals on top of it. And please stay in touch with my channel, and please do subscribe my channel so that I'll be making another video completely for Spark, SQL, and data frame. It's going to be a bootcamp again. And please do follow me in my Instagram. My Instagram is bigdata.in, and I have attached my Instagram, LinkedIn, everything in my description box of this video. And please do subscribe and share this with your friends and colleagues. And I already uploaded a 17 hours of big data complete course video as part 1 and part 2, and that link is also available. If you want to watch the complete course, you can have a look on it. Thanks for watching.